Hi students. As a material scientist, we sometimes deal with sensor materials. When we say that we are dealing with sensor materials, then we can say that we are measuring the electrical property of the sensor material. What is the most frequently measured electrical property of our sensor material? That must be definitely electrical resistance. Electrical resistance measurement is the most frequent case when we study our sensor material. Then, as we are studying the Arduino, so we can ask this: can Arduino measure that electrical resistance of our sensor material? This is the topic that I'm talking with you today. This is the question for today. We want to measure the electrical resistance change of the sensor material to the environment change. Can Arduino measure it? This is a multimeter. In general, we measure electrical resistance very often. We can measure resistance with something like a simple multimeter. It's not just a resistance, it's also easy to measure voltage, current, and so on. How often do you use this thing to measure those properties? It's probably happening very often, very frequently. Can Arduino do these frequently happening things? Arduino, of course, should be able to do it. In fact, for Arduino, measuring the electrical resistance is a very basic task. In fact, we already learned that. We learned analog input last time. This is a typical process of measuring the change in electrical resistance of the sensor. But you'll be asking question. We learned to read voltage values through analog input, not resistance values, right? That's right. We learned to read voltage values. In fact, voltage values can easily be converted to resistance values. Using Ohm's law, you can do that. So reading voltage means reading resistance, in other words. If the resistance value changes, the voltage value across the resistor changes also. Ohm's law tells us that. You will remember that we used variable resistance potentiometer when we learned about analog input. What on earth did that potentiometer do? To understand that, we need to understand the concept of voltage divider. This is the variable resistance, and this is the voltage divider. You don't think these two are the same at all, right? Potentiometer could be expressed in a circuit like this. Look at the circuit. The two are pretty similar, right? Oh, you still think it's different? Well, how about this? If you rotate this, these two look almost the same. When we studied analog input, we connected 5 volts to one end of 3 legs and a G and D to the other end, and A0 to the middle end, A0 for analog input. The only difference between these two circuits is that the voltage divider has a fixed resistance, whereas the potentiometer can change the resistance continuously. Do you get it? I'm sure you do. Now, what value would you read if you connect V out to Arduino in the voltage divider? First of all, since we put the voltage V in on the circuit, so let's say the current I flows, then the V in decreases subsequently across R1 and R2. The voltage dropping through R1 will be R1 by times I, and the voltage will drop as much as IR2 on R2 resistance. Then the voltage becomes zero because it's connected to GND here. This is GND. Therefore, we can see that the applied voltage Vin is distributed to each of the resistance in R1 and R2 ratio. What does this mean anyway? Let's assume a situation. Let's say R1 is unknown and R2 value is accurately known. In other words, you want to measure R1. If you know the R2 value correctly, and if you know the applied voltage correctly also, then you can calculate R1 value. If R1 is the sensor we use, that means we can calculate the resistance value of the sensor. If the sensor changes its resistance value depending on the external environment, and if we could measure the resistance change with Arduino, we finally become able to read a sensor. Let me give you a specific example with specific values. Let's say R2 in this circuit, or the resistance we know correctly, is 1 kilo ohm, and the applied voltage, the Vin, is 5 volt, and the voltage we measured, the Vout, is 2.5 volt, here like this. Then, how much is R1? The calculation is very easy because the voltage of R2 is 2.5 volt. We can see that voltage drop on each R1 and R2 is 2.5 volts respectively, exactly the same. As a result, we can see that R1 and R2 resistance is the same, so R1 is 1 kilo. In other words, our sensor have a resistance value 1 kilo. It's very easy question. Well, how about this? Well, it's also very simple. Please tell me the answer. Measured voltage is 3 volts, which means it takes 3 volts for R2 and 2 volts on R1. You can see that the resistance ratio of R1 and R2 is 2 to 3. Therefore, R1 should be 2 over 3 times R2. R1 in this case, 666 ohm. So we found the answer. If you know R2 exactly, and if you could measure Vout, you will be able to calculate the resistance of the sensor. But one question still remains. We want to measure the voltage, but in fact, using ADC of Arduino, it's a value from 0 to 10 to 3. It looks far from voltage value, right? With ADC 1115, which we already tested, you can read the value from 0 to 65,535, but not from 0 to 5 volts anyway. So we need to be able to convert the value sent by the ADC back to the voltage. How can we do that? We can use the formula here. This will change the value of 0 to 1023 to 0 to 5 volt. It also changed the value from 0 to 65,535 to 0 to 5 volts. Now, do you understand? In fact, what I talked about today is a simple calculation for 7th and 8th grade students. No, actually, is it for 4th or 5th grade? Now that we have solved a very easy math problem, I will give you a very easy homework as well. Using this first formula, display the voltage values that Arduino is reading on the serial monitor screen. You can use what you practiced in lecture 4. The connection between the Arduino and the potentiometer remains the same, and you can add this formula to the code to convert sensor value to volt. Submit the code you write. This time, you don't have to upload a working video. Why don't you have to upload a video that works? You will find out once you try it. Okay, then good luck.